In 3.2, in yesterday's lesson, we said if the lines are parallel, then fill in the blank. Alternate interiors are congruent, alternate exteriors are congruent, corresponding are congruent, same side interiors are supplementary, right? Those 4 theorems. Today we're going to do the converse of all 4 of those. So we're going to say these 4 statements. First one, if corresponding angles are congruent, dot, dot, dot. The second one, if alternate interior angles, do you know what I mean with AIA now, or do you want me to write that out? Shall I just write it out? I'll write it out. If you want to abbreviate, you can abbreviate. If alternate interior angles are congruent, dot, dot, dot. The third one says if alternate I almost did it, sorry. Alternate exterior angles are congruent, dot, dot, dot. And the fourth one is if same side interior angles are what? Congruent? Supplementary, right? So if same side interior angles are supplementary, dot, dot, dot. Okay, so they all start differently, but your response, what comes after the dot, 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 is then the lines are parallel. Okay, so yesterday we said if they're parallel, then the angles are congruent or supplementary, depending on which angles we're talking about. Today, we're saying if the angles are congruent or if the angles are supplementary, then the lines are parallel. So we're proving lines parallel, okay? We would say these are all the converses. So for instance, this is the converse of corresponding angles, right? This would be the converse of alternate interior angles. This would be the converse of alternate exterior angles, and this would be the converse of same side interior angles, okay? So very similar to what we did yesterday, but at the same time still very different. If you're trying to prove lines are parallel, you have to say converse of whichever one, okay? If you're trying to prove angles congruent or supplementary, then use the original, all right? Okay, so first example. Are you guys hot right now? I'm like cooking right now. I swear, I don't know what my deal is lately. All right, this one says, which lines are parallel if angle 1 is congruent to angle 2, and tell me why. Okay, and here's our picture. Here's line L, bless you, M, bless you, A and B, you're welcome. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we have all these different types of angles. Notice that none of the lines are marked parallel right now, okay? So your questions are gonna be similar to what you had yesterday, but now instead of saying these lines are parallel, tell me the measure of the angles, now they're gonna say if these angles are congruent or if those angles are supplementary, which lines are parallel? So you're trying to determine which lines are actually parallel here, okay? So we're looking at angle 1 and angle 2. And what I like to do with these is, if you can't see it, if you can't tell which lines are actually parallel right now, draw or highlight the angles you're talking about. So angle 2 is that, right? Angle 1 is that. So if you think about where your highlighting falls, you are on line A, line B, and line M. Which lines are the parallel lines? A and B, right? Those would be what kind of angles? 1 and 2. Those are corresponding, right? So we would say A is parallel to B by the converse, because we're proving lines parallel, of corresponding angles. Okay? If you're proving lines parallel, it has to be a converse. Okay. Same picture. What if I say angle 4? No, let's do it this way. Which lines are parallel if angle 1 is congruent to angle 4? And tell me why. So if angle 1 is congruent to angle 4, which lines would be parallel? Do you see it? 1 and 4. First of all, what kind of angles are 1 and 4? Alternate interior angles, okay? So you're going to be using the converse of alternate interior, but which lines are parallel from those two angles? L and M, right? So if you look at this setup, angle 4 is here, angle 1 is here. Looking at my green, A is my transversal, L and M are the two lines that are parallel. So we would say L is parallel to M by the converse, because we're proving lines parallel, of alternate interior angles. Okay? Does that make sense? Yes? Any questions on that? Okay. Example 2. Sometimes you're going to see flow proofs. Have they done any flow proofs for you yet? Have you seen, do they say write a flow proof? I don't know that you've seen one yet. Okay, today you're going to see flow proofs. A flow proof is really like a 2-column proof. It just takes you through, like, I know these two things are true. That leads me to this thing that's true, which leads me to. So it's very similar in the setup of it, but instead of 2 columns, you're kind of working your way through like a, what would you call it? I don't know. Not a chart. It's a flow proof. You'll see. You'll see. You don't ever have to do a flow proof for me. So the book, some of the questions are flow proofs. You'll always do 2-column proofs for me. So don't worry about paragraph proofs. Don't worry about flow proofs. You're going to get 2-column proofs. All right, here it is. If you are given angle 1 is congruent to angle 7, and they ask you to prove L is parallel to M. And here is your picture. This is line L, line M, angle 1, which they say is congruent to angle 7, angle 5 and 6, and angle 3. Okay, something I want you to think about. When you are proving that lines are parallel, what did I say you have to use? Do you remember? What were those first 4 theorems? They were all converses, okay? So you should know right now, looking at this proof, that my last step is the converse of something. We don't know which one yet, because we don't know how we're going to get there, but the converse of something should be your last thing, okay? All right, what's your first thing? The given. So you're going to say that we know angle 1 is congruent to angle 7 because it was given to us. Okay. Is there anything else that you know to be true in this picture? Just looking at the picture, anything that you know is congruent or
3 and 6 are same side interior angles.
3 and 6 are same side interiors. Okay, now here's the deal. Did they tell us the lines are parallel? No. So do we know the angles are congruent? No. They look like it, and we're trying to prove that the lines are parallel, but because we don't know the lines are parallel, you can't use those theorems to prove that the lines are parallel. Does that make sense? You have to know the lines are parallel, and we don't. Yeah. Okay, we do know that angle 1 is congruent to angle 3. How do we know that? They're vertical angles. And if it helps you to mark it as you go, just so you see it, that's fine. You can totally mark that. Okay, so because we know 1 is congruent to 7 and 1 is congruent to 3, we can say what? 3 is congruent to 7. And what is that? It's not by corresponding because we don't know it because they're corresponding because we don't know the lines are parallel. It's the transitive. I heard someone say it. It's the transitive property because we crossed out the two that are the same, right? Or you could say substitution. Okay, so that's the transitive property that says 3 is congruent to 7. So now we can say because 3 is congruent to 7, line L is parallel to line M by what? Converse. Good catch. The converse of corresponding angles, right? Those are corresponding angles, and if corresponding angles are congruent, then the lines are parallel. Okay, so that's your converse. Do you see how much transitive and vertical show up in proofs? Really, if you can just remember the common things that show up, you are like a step ahead because you see a lot of the same stuff over and over and over again. Any questions on that one? All right. Yes, Jason.
Could you just use the converse of alternate exterior angles?
Yeah. Right there you could because you know they're congruent. But I want to take you through the process of a proof, so we don't. But yes, you could right there. Okay, example 3. I want to know, are the lines parallel? Okay, so they don't tell us the lines are parallel, but they do tell us that angle 1 is congruent to angle 2. Okay, if angle 1 is congruent to angle 2, are the lines parallel? If so, why? If not, why not? Do you know what kind of angles those are? Alternate exterior angles, okay? And there's a theorem that says if alternate exterior angles are congruent, then what? The lines are parallel, okay? So are the lines parallel? We would say yes by the converse of what Jason was just talking about. Converse of alternate exterior angles. And like we did in the last one, you could have done the process of, we know 3 and 2 are vertical. Transitive property would then say 3 and 1 are congruent. So you could do the converse of corresponding as well if you wanted to work your way through it like that. Okay? All right. Last one, and this one is going to look really similar to what you did yesterday. It's just the way they word it is different. It says, what is the value of x for which line A is parallel to line B. Okay, you don't do anything different than you did yesterday. It just is worded differently. So they didn't tell us A and B are parallel, but they say if we want them to be parallel, then what would A have to, or what would X have to be? And they tell you this angle is 2x plus 9, and they tell you this angle is 111. So in order for those lines to be parallel, what would have to be true of those two angles? They would have to be supplementary because they're same side interiors, right? So what you're going to do is exactly what you would have done yesterday. 2x plus 9 plus 111 should equal 180. So simplify that. 2x equals 120. Take away the 120, so 2x plus 120 rather. Sorry, not equals. 2x plus 120 equals 180. So 2x equals 60. Divide by 2. So x would be 30. And for that one, it's just find the value of x. So you don't even need to plug it in to find the other angle, although you could, just to double check your work. Questions on that? Okay, that